Hey everyone, welcome to my channel. In this session today, you'll be learning about how to deploy AWS EKS cluster using Terraform and there deploy a 3-tier multi-service architecture application and all that with monitoring. So what you're waiting for? Let's get started. And before you get started, if you are not subscribed with my channel yet, please do subscribe to the channel. And now I think you have done it. So let's get started. Now, before starting all this, make sure you already have installed kubectl, Helm, and of course AWS CLI. You will find this particular this repo, and I will share the link in the description as well as in the first comment. So you can just quickly go to this particular GitHub repo page, and you can just install the prerequisite, and you'll have all the codes. Now, after you're done with installation all these prerequisites, now this is time for the next step, which is to have the AWS IAM credential creation. Now, you can avoid this step if you just, instead of creating IAM credential, you can just create one IAM role. I'll just show you how to get the role and all that, both configuration. That way you can avoid IAM creation. So first, let me show you how to create the IAM credential creation. And if you want to avoid it, what to do for that. Let's do it quickly. Now, first, let me show you how to create the IAM user. Okay, so go to first IAM and there you will see the users tab, and there you will see you have to create the users. Okay, so this create user, there you just click it, give a name, say my local setup. Okay, whatever you want to give it. Next, then the access. So attach direct policy. Now you can give it refined permissions, but for our demo purpose, we'll just go with the admin access. Okay, so administrative access. Go down and click on next and click on the create user. After the user is done, so my local, this is the one that I've created, right? Go there and see this tab security credentials. Go there and create the access key. This part, okay? Create the access key. So just click on this and for what? So for CLI, right? So command line interface. Click on that. Go down. Click on next. And okay, I have to tick on this. So next on that. Just avoid this one. You can skip it. Done. So this is basically it. So you have to come into your local, and in the local you have to simply do AWS configure. Okay, and if you do that, it will ask for the username, I mean the key access key, and then it will ask for the first, and if you do that, first it will ask for the your key ID and the secret key, and then the region, then the default out format. I will ask you to do JSON and all that. Now, if you want to avoid creator of this personal credentialing key, which sometimes can get leaked and create a lot of problems, you can avoid all these things altogether. How you can do that? And that's actually an easiest step. So for that, what you have to do, instead of creating IAM user, you can create a role. So first go and create a role. So click on just create role, and then for what? AWS service. In the use case, select EC2, then go down and click on next. Then same administrative access, go down, click on next, and just give it a name. Say we can call it a Terraform role. Okay, whatever you want to give it, you just give it the name. Go down, click on role, and it will create a role for the Terraform access. Okay, now let's go to EC2. Go there, and then just click on this launch instance, and this for our demo purpose, we'll say call it Terraform instance. Okay, go down, select whatever the OS that you are preferring to. I'll go with Ubuntu, and just below go down, all seems good. Now if you already have a key pair, you can go with that. If you do if you already have the key, now if you already have the key pair, you can go with that. If you don't, you can just click on this create new pair, and you can just go ahead with the new key. I'll just skip them because I already have the key, and that's all you need to do. Just launch the instance, and after the instance is up, let's just wait for that. This instance, you can just go to the instance details and right click, and there is an option called security. See, it's not allowing you to modify the IAM role because it's still on the it's still updating. Okay, so once this, instead of pending state, it's on the running state, you will be able to update the IAM permission or IAM rule for that particular instance. Just go and just check. Just wait for a few seconds and it will be up. Now you see this instance up and running. So just right click on it and you will see the option in the security called modify IAM role. Click on that and see it's asking to select your IAM role. So we'll call it, the moment you remember we created a Terraform IAM role. So just search for it and see Terraform role and simply go and update the IAM role, and that's it. Your instance will have the all the access that you require to create the EKS cluster, whatever you want, because I've given admin access, but you can fine tune it later on. Again, you can just adjust this as per your requirement. Okay. Now you can of course utilize this instance, and from there you can do all this cluster setup and all. Now for me in the local setup I already have done it. So for the demo purpose, from now on I will just show you how to get it done within the local environment. Okay. Now since your IAM setup is done, you are ready to create the cluster. So how can you create the cluster? First, let me just clear the screen a bit. Now, if you see our application architecture, in app, we have the application codes and the Docker code, of course. In the cloud formation, I just keep it for future. K8 manifest, you have all the Kubernetes manifest files, and Terraform, where we have all the Terraform files using what we will be creating our cluster. So you will have all the codes, and I will explain all the things. Before I explain all the codes, I want to go ahead and start the get the cluster first, because it takes 15 to 20 minutes to create the cluster. And while the cluster goes on and creation and will happen, I will keep explaining all the codes, all the Terraform codes to you guys. Okay, so let's get started. First, go inside this folder Terraform. Okay, so cd Terraform, and first command you have to run Terraform init. Terraform init will install all the plugins and modules that will required by Terraform, and after that is done, let's let this. Now make sure the code that you will be writing and all these are fine. So for that you run Terraform validate. Okay, it makes sure all the syntax are proper, and after that we just have to plan and see what are the resources we're going to create. Just wait for a few minutes for that. Now it's all condition valid. So then Terraform plan. Okay, it will take few seconds and then it will give you entire detailed of the resources that's going to get created by the Terraform. Okay, seems 77 resources that Terraform is going to create, and I'm fine with it because I've already tried multiple times, by the way. So now then let's try Terraform apply. Again, it will just before applying all these changes and all these resources, it will ask you for the confirmation, and just need to confirm it. And again, just wait for a few seconds and it will be ready to apply. Oh, it's done. So just say yes, and it will start creating all the resources that is required for the AWS EKS cluster. Not just that. Now let me start explaining all the resources that this Terraform file is going to create, and what are the reasons why this creating, right? I'll explain all of it. Now let me start explaining all the Terraform files that we have here. First, let's start with the variables. Okay, now what are this? So in variables, you have to specify the cluster name, you have to specify the cluster version or the Kubernetes version, then the region, then the availability zones, then the add-ons part is that Terraform for say core DNAs or proxy, or for the drives, the volume driver, you can specify like kubeproxy, CNI, core DNAs, CSA driver for the e-base. You can specify the version that you want to install for your cluster, and you can specify all that here. Now for that particular file for the add-ons, I have already commented that one, but you can simply go on and you can install if it's required. Okay, so this one CSA driver, for one example I was doing that. So just giving you one hint, you can enable like this way if you want it. Now let's go back to the variables again. So you see the variables, the cluster name, cluster version, all that. Now the next thing is the VPC. In the VPC you'll find it, the VPC where I'm going to use the modules so that we can reduce the number of lines and number of codes, because modules are already kind of approved, kind of reviewed by many engineers around the world, and it's much stable. Okay, so what we're going to do here, we're first going to use the module VPC. There already have the URL of the VPC, the version that you want to use for your VPC resource creation, then the name of the VPC, then the base CIDR of the VPC, then availability zone. Now you already know that we have specified the availability zones variable in our variables.tf. Okay, that's coming from here. I will just show you. Yeah, availability zones coming from here. You can always rewrite it or override it, whatever you want to do, you can do it. Just as an example, I've given it so that you can make it more dynamic if you want to. Okay, just go down. In there is two things you need. Okay, because the application server, the data server that you'll be running, or the data server containers you'll be running, that you should run inside the private subnet. Okay, and for the load balancer that will be running, for that we'll be using the public subnet. Okay, that's why I'm creating one private subnet group and one public subnet group. Okay, and I'm just creating some tags to automatically configure the load balancer for this. Okay, now I'm enabling the net gateway. Now I'm enabling the NAT gateway so that because the pods inside the private subnet need to access the our ECR repo, right? So that from ECR it will download all the images, or maybe it need to download some other things, some passing and all that. It could be anything that it require the internet outside access, not the inside. Okay, so from the inside of instance, it can access the outside of resources. For that, we are enabling the NAT gateway. Now we don't want to run all NAT gateway for all availability zone. That just increase the cost. We want to reduce the cost. That's why we are running single NAT gateway, and you are not running one NAT gateway per availability zone. You just want NAT gateways to enable the internet from the instances that are running on site the private subnet. Okay, we are enabling the core DNS support and that we are enabling the hostname support and the DNS support, so that Kubernetes require all these things. That's why. Tags environment, you can add any tags that you require. Okay, so that is the VPC. Now this is the only basic things required to create the EKS cluster. Yes, now let's click on this, just go on this EKS.tf and we'll find it. Again, we are using modules because we don't want to reinvent the wheel. Just there are already resources available, why not use them? Okay, that's the reason I wanted to emphasize on using the already available modules. Okay, now again, source, you have to give the source path of the module, the latest available will be better, and give the version. Here we are using some variables like what is the cluster name, cluster version, and all these values are coming from the variable file. Then do you want to enable the private access, private endpoint access? Do you want to enable the public endpoint access? Then what is the VPC? Now you need this VPC ID. That's why we are creating the VPC resource here. Okay, now let's come back to the EKS again. Then enable the IRSA for the authentication. Enable EKS manage node group default how much will be the default disk size? 50 GB. Then EKS manage node groups. Here we specify like what are the general instances. Now here is two types. Okay, general and the spot. We'll be utilizing both. So in the general, we're specifying here how much basically desired instance numbers, minimum and maximum number of instances that you want to run. Same way. Okay, here you can also mention that how many or what are the instance time that you want. Okay, like T3 small or maybe M5 large, whatever you want, you can specify here. Then on the spot also you can specify like, I know this is again based on the availability. If it have the spot, it will just grab from the spot fleet. If doesn't have the spot, then it will default back to the general instance time. Okay, now that is where again here also you are specifying like what is the spot and what should be the spot instance type. Okay, this is all we are doing for the instance type inside the EKS node groups. Okay, so then go down, manage AWS auth config. So we are giving EKS module to have the access to our config map. Then what are the authentication role that you want to give to this particular EKS setup? And you see EKS admin IAM role, we're just creating and assigning it here. What it can access? The system masters. Okay, now this is where the ingress controller we are setting up. You can find it here, ingress on the 9443. This is all to set up the nodes to node access part. Okay, and we are again this tag part, you can add whatever amount you want or whatever number of environment tags you want to add it. Now then we are EKS cluster default. We're just creating some data sources will be required here and there. For that reason, just the EKS cluster default, EKS cluster auth default. Then okay, this is the part where actually if you see there's one particular file that is called provider. In the provider we are specifying what are the plugins that will be required. Okay, there we had required the kubectl, then the Helm. Now these two are required because we are using kubectl to automatically allow the Terraform to make the Kubernetes changes, and Helm to again similar reason but to install additional resources like load balancer. Okay, I'll come to all that. Just let's go down to the this part. EKS part we're explaining there, right? So Kubernetes using that will be like Terraform could maintain the EKS resources or the Kubernetes resources if you configure that properly. Then if you go down after that one, you see like after the cluster is set up using EKS, you have to set up the autoscaler so that as per the demand, the number of instances it can add or it can remove, so that it can auto scale properly, like horizontal scaling part. That we are taking care of using the autoscaler manifest. Here I have all the resources that is required, all the configuration that is required to make sure our Kubernetes cluster, the EKS cluster, can scale as per the requirement. And I have specified all that thing here. This is so long. If I start explaining, it will take a lot more time. But just make sure that it have already like everything that is needed for the auto scaling to the clusters. Okay, that is all set. Now for that auto scaling to happen, of course, the cluster requires some authentication and access. For that, in autoscaler IAM, we have set up all the access that is required. Again, we are emphasizing on using modules so that we can reduce the manual effort, okay, and the number of lines that we use. Okay, so now all this is done. Now the next part is on, okay, there is one backend part. Now for that backend, I have specified my personal repo. But when you get, but when you download the repo, make sure that you make change to this particular bucket so that it is your bucket, not my bucket. Okay, so you have the access to the bucket. And if you just go down, there is Helm provider. We are setting up the Helm, so that Helm, using Helm, we can install or download some packages. Now, if you're not sure what is Helm, it's kind of a package manager for the Kubernetes. You can just install package resources using the Helm. Okay. Now, using this Helm load balancer TF file, we are installing the resources that is required for the automatically creating of the AWS load balancer, specifically the application load balancer. Okay, so we are configuring all that here in this particular Helm load balancer part. And in the IAM part, if you come here, it's mostly taking care. Again, we are more using module. So all the things you will see, will be using modules heavily. If you see my past 3 or 4 year back videos, there I have mostly used the raw, say, basic level components or resources. But I came to relation while working on different projects that is better to use the modules. Okay, here modules, you are using the access that is required to create the IAM role and all the requirement. See, use it. So in future, when you have many other developers get added, so that you want to give them access, just like I have given here, user one IAM user, you can just keep adding 2, 3, 4, how many numbers you want. Okay, and then you can go, just you see in the few minutes back you saw how I'm creating the access for the particular users. You can similar way create the access and give to other users, right? That will be easy to manage that way. Now in monitoring, I will show you after this basic setup is done. I will show you how you can configure the monitoring part using Prometheus and Grafana. For now, just to make sure our cluster is actually ready, if you come here and see, all our cluster is actually ready. 77 resource added, 0 change and 0 destroyed. So our cluster is ready, and I'm done with the definition, like explaining all the code also, because we are using modules, and using modules is so less codes and it's easy to integrate, and you can of course keep adding other resources easily. Okay, now our setup is done. Like this particular Terraform part is done. We have everything is ready. Now let me just clear the screen. Okay, and there simply add just go to readme. Okay, and preview of the readme, so that you will see what are the things. So prerequisites are done. You have already installed. Now if you want to verify the access, you can run this kubectl auth can start. Okay, but before that, just go down, and there should be a part where maybe up this one. Okay, AWS EKS update kube config region and your cluster name. Now this is all to make sure that in your CLI you have all the basic access configured, and it will update your local kube config file. So let's run it and see, it will just say context updated. And if you run AWS EKS, not just AWS EKS, simple kubectl get nodes, it will say that we have the nodes up and running. You see, ready. So our things are ready. Now since this is ready, we can now just follow the readme again easily, and there you will see what is the step by step next way. Just run this one to make sure that you have all the access that is required in your Kubernetes, and we will say All okay, that you have, yes, you have all the access, this one. Okay, so we have all the access, we are all set to now applying our next number of resources. Now let's go down, and if you go down and down, I think this is easier if I just show you in our browser. Okay, so you see autoscaler, our, make sure your autoscaler also running. Yes, so let's make sure our autoscaler running perfectly or not. So let's go down and just clear the screen. Yeah, our, see, all our load balancer, controller, nodes, code DNAs, cluster autoscaler, group proxy, every single thing is running. So we are kind of all set, right? So since you're all set, let's start our actual application deployment. Now let's clear the screen and go inside this K8 manifest folder. Okay, so cd dot dot, go to browser directory, cd K8 manifest. There, first run this one. Okay, go to Mongo, cd Mongo, and there first run kubectl apply f, then the secret. Okay, make sure you apply this, otherwise you will see a lot of problems happen. First step is to actually applying the secrets. Okay, because see the problem, we didn't created the workshop namespace. So let's just go ahead and create the namespace first. See, create namespace. So kubectl create ns workshop and make sure you make it default namespace. Okay. That's it. Okay. Now if we just go and run this one, apply secrets, it will work. Yes, and you can just run kubectl, then just deploy and the service. So kubectl apply dash f, then the deploy.yml and the service.yml. Now let me show you. In deployment, it's just creating like simple MongoDB container in a pod, and in the secret we have the secret username and password. In the service, we are running, making sure, because pod will up and go down and all these things happen, right? The service will make sure it will always connect to the available pods. That's why. So all these things are there. Okay, what happening? Oh, one issue that if you are specifying multiple manifest file, every time you have to give dash f. Okay, so just do that, and it will create the MongoDB pod and container and the service. Okay, so you can run kubectl. Let's clear the screen and run kubectl get pods and svc, and that's it. Because our default namespace is that workshop. Because this video actually I'm making because many people didn't able to attend the workshop in AWS community, so I'm making sure everyone have access to this container resources. Okay, you see pods is running, you see the service running, so we're done with the MongoDB. Okay, let's go back and then create the rest of the resources. First, we are going to deploy the backend service, because first make sure that you have the MongoDB up and running, and then connect the backend service. Then only it will work. Okay, so cd, then just run kubectl apply. First one is the backend deployment and dash f. Make sure you have that dash f for that first one also. Dash f backend deployment and the backend service. Okay, and it will deploy the backend deployment, where specifically mentioning like what is the backend image, the like making all the levels so that it will automatically match the levels and drag the traffic and all that things. Okay, making sure the container is the container port of the application, making what is the path to make sure the application up and running, and all this basic required minimum things that you should do to make sure our pod is running properly and allow the traffic to come there. Okay, just run kubectl get pods, and let's see all our pods are up. And see, okay, it's getting ready. So it will take few seconds to make sure that our all backend things are running. Similar way, just how I run the backends. Let's run kubectl apply dash f for front-end deployment and the front-end service to be ready. Just let's wait for that. Okay, again just run kubectl get pod and see all our front-end services are up or not. Again, container creating, it will take few seconds and it will be also up and running just in a few seconds. Okay, it's container creating, and we'll have the container starting in a moment. Now, sometimes it may take time because maybe your cluster don't have the resources, and you can see that kubectl get nodes, that your nodes are auto scaling. Okay, see right now it's enough into, but the more resources you add, the more number of pods you add, you'll see as per the resource that you are specifying, the cluster will auto scale based on the requirements or the number of resource requirements. Okay, so you're all set. We have everything running. We have our MongoDB running. We have our let's see, all services and pods are up. That way we can make sure that we run everything. So all our services are up. Okay, all our containers are up, and like application container, front MongoDB is the data layer, front end is the front end layer, the back end layer, all are up. Okay, so we are all set. Now let's go down again, just make sure everything is up and running. I think yeah, all looks good. Everything is up and running. See number of replicas now, because you can run 2 or 1, and just make sure that I'm just running 1 because to reduce the load. Okay, so kubectl apply -f, then backend deploy, so that we can just minimize the number of replicas, and we can run other, because we'll be running that monitoring also, right? I'm just clearing some things. Let's see if our things are all set. Okay, so yes, terminating because we already have 1 running. I have said make sure 1 replica only, right? So all set there, our backend, front end, everything. Now the final part, okay? And we have the full stack load balancer. How it works? So we are creating a ingress, okay? So to like from outside internet traffic, all coming to our first the ingress load balancer, and then it will automatically directing the traffic to the services that we are configuring. Okay, so first what kind is ingress, then the name is main LB, and you can give it anything namespace that you want to this to work. Scheme internet facing, so you want to allow the internet traffic. Target type IP, so because you are specifying the cluster IPs. Okay, and here ingress name ALB, you can then after that, now this is important part, rules. So what should be the host name? Based on the host name, it will allow the traffic, otherwise it will not allow the traffic. Then what is the path? So in our backend application, if you see in app in the backend, and if you see that index, we are accepting the traffic in the API then task, because it's a simple to do application. Okay, nothing very extraordinary, simple application. Now you can make it extraordinary as per your requirement. Okay, so this is simple API task. It's a CRUD API. It's creating the resources, updating the resources, and deleting the resources. Simple CRUD application, nothing else. Okay, so just go back to manifest again, and there just full stack LB. So all the backend traffic we are forwarding to the backend service. Okay, see service name is API. So if you see our backend deployment, the service name was the API deployment, but this will go down. The container name was API, and the template, like this will, based on the label matching, it will redirect the traffic. So make sure you are configuring properly. Okay, now go back again, and if you now this is the deployment. Actually, the service name it should be right. So if you see the backend service, then the net name is the API. Okay, so when the full stack load balancer getting the traffic on /API is redirecting the traffic to the API service. Okay, that is you have specified in the backend service on the service file here. Okay, based on this metadata, make sure you specify that properly, otherwise you will see the traffic is not redirecting properly. Okay, now let's go to the full stack. Now for API you have done it. Now for the what is for the HTTP or the HTML or the front end, for that any traffic other than the API, it will just come and get served from the front end. So you see, I'm not using multiple load balancer. I'm using one single load balancer to load balance the traffic front end and back end based on the URL pattern. That is one very good way to reduce the cost as much as possible. Okay, and again for the HTTP this path, the backend is the service name is the front end. Again, if you just go to the front end service, you will see the data name is the front end. So that's how the traffic getting forwarded to this particular service. Okay, and if you see, that's what this front end service is doing. It's getting the traffic and forwarding to the port 3000 of this front end pods. That's how we are configuring things, and that's how we're doing. So only missing piece here is that this one, the kubectl apply -f, then the full stack lb, and that's it. You are deploying the load balancer that way. And this load balancer, to work, make sure in the Terraform, Helm provider and Helm load balancer configured properly. Okay, this was the thing that is required for this load balancer to work perfectly. Again, for the load balancer credential on these issues, it will work exactly, because that's how I've configured this Terraform file. If any issues, in the readme I've given instruction how you can debug this. Okay, now let's see kubectl get ingress, and this will give you the load balancer URL. So make sure the load balancer and the URL in this particular K8 manifest full stack will be. Now this is what I am specifying here in the app dots and the dots. For your case, the domain name will be different, right? So you should be, whatever your DNS provider, go there and give, add this particular CNAME. Okay, this is a CNAME, and update that one or create the record. Let me show you. For me, it's sandeepdas.in. I'm hosting that in the Route 53. Now, since I'm hosting the domain in Route 53, let me show you here. Now, for your case, it could be anything, any other domain hosting. Just make sure, go there and create a CNAME record. Okay, for me, this I think already have the record, but you can just click on the create new record, and while selecting, just make sure it's a CNAME. See, then the type of the record is CNAME. So just go there and let's edit it. For me, I will just quickly go ahead and update the CNAME. So let's just copy from here. Just copy the CNAME and let's go to the browser and update it. Okay, just save it. That's it, and it will take few seconds or sometimes few minutes to update, and let's wait for that. I'll show you how the application is working. Okay, now I think I wait for 2-3 minutes. Let's see if that particular domain working fine or not. So app.sandeepdas.in, yes, it's working. It's a simple to do application. Okay, so let's say hi guys or hi everyone. Hope you like this video. Yes, so this root task, just delete it. Now, what is the next task? Is to have the monitoring. So monitoring. So you understand, right? Now let's set up the monitoring part. Let's go to our application codes, and if you see this particular part, just go back in the Terraform, and monitoring I've commented it. Okay, so just uncomment it, and again, guys, by now you guys know it how to make ready the that Terraform part. So first Terraform init, so that if any module I'm using, okay, let's go to Terraform folder first. So Terraform init, and yeah, it will just see anything, because if you just go down here, I am using some modules here, right? Prometheus, Helm, release Prometheus. So some automated packages that will make sure everything is set up for Prometheus and Grafana without a sweat. Okay, and everything is installed. Now Terraform plan, to see that what are the resources is going to create. I think it's 3 or 4 resources probably is going to create. Now let's see how many resources is going to create. And see, this project is actually so good that it's not just creating a setup, it's also taking care of monitoring and everything, like auto scaling, monitoring, everything is taken care of, right? Sounds great, isn't it? So let's go, man. Yes, this thing is. See, it's asking to add 3 resources. Now run Terraform apply. Again, it will just go and it will ask for confirmation and say yes, and it will create the resources that is required for the and it will go ahead and create the resources required for the monitoring part. Okay, using Prometheus and Grafana, of course, and it takes around 2 to 5 minutes based on the cluster size and the available resource and everything. Just wait for that. So it took around 5 minutes for the monitoring to set up automatically, by the way, by Terraform, and nothing manually. Only one thing you have to do, just from the cluster IP, to make it a load balancer, so that you can add a new domain for that. I will show you. very quickly how you can achieve that. So go to the readme part and just go down, very down, and just let me show you. Okay, make sure that all the services for Prometheus is up, and just clear the screen, and there we'll see it. See, all the services are up, and you can see the cluster IP are also assigned. Now this particular part, okay, this Grafana. See, this is cluster IP. Now instead of cluster IP, I want to make it a load balancer. Let me show you how I can do it. Okay, how we can do it. Okay, so this particular command kubectl edit svc Prometheus Grafana -n Prometheus, because this is the namespace where the services and pods are running. So just edit it and just go down. See, there the type is the cluster IP, right? So instead of cluster IP, make it a load balancer. Okay, this particular just go down, load balance. Turn into edit mode and then go and paste this and just save it. Okay, and see, this will automatically apply the changes, and see if that now instead of cluster IP, it become a load balancer. No, by mistake I did the exactly same thing. Okay, let's go and make sure that our service now load balancer. And if you come here, you see this part, this particular part here, where instead of now cluster IP, it's become load balancer, and we have a particular one load balancer here. Okay, so copy this, and again let's go back to our Route 53. Now here for me it's Route 53, and see how monitoring is done actually. You can even apply in the browser. Okay, it takes some time, of course, because just right now we created. So just make sure that you go to Route 53 there, and let's add a domain call monitoring.sandeepdas.in. Okay, let's do that. Create a record. Again, it's CNAME, so monitoring. Okay, monitoring dot and CNAME, and this is the domain I want to redirect. Okay, so let's create the record. Again, we can always check the progress of the load balance is ready or not. Okay, so we can go to the EC2 or just load balancer directly if you want to, and there just look at this load balancer part, and see, this is not active yet. This is the load balancer, by the way, and this is not active yet. So state to active becomes some 2-3 minutes. It takes time, so just wait for that to happen. And I think, yeah, it's already set up and ready. And let's see by the domain also it's working or not. So like instead of this, like directly this, let's see by domain we can access or not. Okay, so monitoring dot Sandeep dot, and see, now via domain name we can easily access it like this. Again, what is the username and password? If you see our repo, there itself I have mentioned it. This is the default one, by the way, and you should change it after you're done with your testing and all that. So username is admin, and the password is the prop operator or prom operator. Now you can, of course, after login you can change it, and you should be changing it, by the way. Okay, now if you, I mean, this is nothing, you can see nothing, right? So now let's quickly set up a dashboard. How can you do it? So we will quickly import this one. Okay, and you can of course go to this particular site and import whatever your choice based on your requirements and all that. You can always import a particular dashboard. I found it is very good one. So search for the import page, import dashboard, and here paste it, load it, and simply select the source as Prometheus and import it. It will take few seconds, and boom, it's ready. It's showing you the CPU part, system load, and all this, the data that you need. Okay, all this kind of data that will be useful for you, it will be coming in this particular page. Wow, so we set up an end-to-end cluster within, and it's not even an hour. How easy it is. I hope that you will be doing the same thing, and maybe something even better, something more useful that your project. Okay, now it's all good. We set up what we set up a EKS cluster using Terraform. We will set up all the three-tier application, and it's a microservice architecture end to end, including presentation layer, that is the API, sorry, the React JS application front end, the API backend, that is using the Node.js part, and data store MongoDB, and it can be any data store based on your requirement. So we have set up everything that is required, and not just that, we have even set up monitoring here. How cool is it? Okay, now we have set up everything, all is fine, but if you keep it running, it will cost you a lot. So if this is a project for you, just experiment things and all. At the end of your implementation, everything is working fine and all that, you might want to destroy all this cluster and everything to save the cost. And what is the way to do it? I will tell you exact steps. Okay, just follow now. Now to clean up all the resources, what you should be doing, first, don't just go to cluster first. Okay, first go to the Kubernetes resources. So K8 manifest. Okay, so go to K8 manifest and run kubectl delete -f and dot. So whatever the resource that it might have created, it will just keep deleting everything. That's done. Okay, let's clear the screen. Let's go to Mongo because we have MongoDB resources. So kubectl delete -f and dot again. All the MongoDB resources also it will delete. And that's it. You have cleaned up all the MongoDB resource and everything. So that's it. You have deleted all the MongoDB cluster resources that we have created via these manifest files. We're done with that. Now let's go back and go to the Terraform folder. Okay, here we have the cluster and all this resources, right? So here run kubectl destroy. Okay, and that's it. It will just check all the now go to this Terraform directory, and now let's go to this Terraform directory and run Terraform destroy. Now again, it will just go and check what are the resources recently created and active, and then it will ask for confirmation to delete all the resources. It will take few seconds for the list to come. Just wait for that. Okay, so it seems ready. See, it's adding 0 to add, 0 to change, and 81 destroy. Now make sure you are 100% sure to destroy all the resources. If you just by mistake did you run it, don't say yes. If you are sure that you want to destroy all the resources, now this is the step, and say yes, and it will destroy all the resources that you have in the cluster. Okay, so we are done with the cluster resource creation using Terraform, setting up all the fancy stuff, the front end, the back end, the database, the tier, and not just that, we have of course implement monitoring. So I hope you like this video, and if you did like this video, please do subscribe my channel and click on the bell icon, by the way, and share this video as much as possible. See you soon in my next such interesting video. Bye bye.